Hello students, this is Mrs. Denton, and in this video we're going to be learning all about symmetry. We're going to really be learning and focusing on two different types of symmetry. One of them is called line symmetry and the other is called point symmetry. Line symmetry is when a figure or an image or a picture, whatever you want to call it there, when a figure can be divided by a line. When a figure can be divided by a line into two mirrored images. So I've got a couple of examples here about figures that may or may not have line symmetry, and it's our goal to draw a line of symmetry through each figure. So let's start with the heart. You're trying to think, where can I draw a line that will divide this image into two mirror images? So you couldn't go horizontally because the bumps of the heart are not down here on the bottom. We would go vertically. So our line of symmetry go right through the crease in the middle of the heart. That way, everything on the left is now a mirror image of everything on the right. We could fold this heart in half and the two halves would line up with each other. Go through and see if you can find at least one line of symmetry through each picture. All right, so check out my images here and see if we came up with the same lines of symmetry. On the smiley face, the picture of the face does matter. We couldn't draw a horizontal line or a diagonal line on this circle due to the smiley face. So I tried to draw a line right down the middle. It does look like I'm a little off center. I don't have a perfect eye, but I tried. On the D, I drew a horizontal line here. Now, not every font would have a horizontal line of symmetry, but this particular font of D does have a horizontal line of symmetry. Batman is symmetrical, drew it right down the middle. We could fold the left wing onto the right wing. And this little funky pie circle over here with a piece missing kind of looks like Pac-Man, but I purposely didn't put Pac-Man's eye on it because if Pac-Man's eye were up here in the top corner, it would not be a symmetric figure. As it is, blank, it is a symmetric figure. Now, sometimes you're asked to find all the lines of symmetry in an object. You'll have to draw multiple lines of symmetry in. So let's do a couple practices here. Let's start on the sun. Okay, use a pencil, make sure you have a ruler. There are a lot of lines of symmetry here on the sun. We could start vertically and go through these triangles that represent the rays. And truly, we could go through any triangle pair, and that would be another line of symmetry. So we could go all the way around the sun here through each triangle. So I'm up to 3 lines of symmetry, up to 4 lines of symmetry. Now that's already pretty detailed, but there are more as well. You could actually draw in a line of symmetry between the triangles. Now this is going to be an estimate here because I don't have any direct measurements, but between the triangles is another line of symmetry. Boom. So I'm up to 6. There's another one between the triangles. 7. And finally 8. So this one image has 8 lines of symmetry in this one image. Very, very symmetrical figure. See if you can go through the rest of these images and determine how many lines of symmetry they have and draw where they are. All right, let's compare. On this second image of the double-sided arrow, I found 2 lines of symmetry. We could fold it horizontally and the top and bottom would meet. We could also fold it along this vertical line and the left and right would meet. So I've got 2 lines of symmetry here. With the star, I found 5 lines of symmetry through each point and out the other side for a total of 5 lines of symmetry. And finally with H over here, again, I picked a font that was very symmetrical. I got 2 lines of symmetry. I can fold this H vertically or horizontally. So line symmetry is when a figure can be divided by a line into 2 mirror images. Sometimes we only have 1 line of symmetry, like these first 5 examples, and other times we have multiple lines of symmetry. The next type of symmetry I want to talk about is point symmetry, and this may be new for you. Maybe you have not learned about point symmetry yet. Point symmetry is when every point of a figure has a matching point that is equidistant from the point of symmetry, but in the opposite direction. I'm going to write that down, and then I'm going to show you several examples. So point symmetry, when every part of the figure has a matching part equidistant, we've used that word quite a lot, equidistant from the point in the opposite direction. Okay, that's rather long definition. Point symmetry, when every part of the figure has a matching part that's equidistant from the point in the opposite direction. Now that's a lot going on. What I want you to do right now is pause the video, and you're going to take your strip of shapes that you picked up. You've got 1 plus sign, 1 parallelogram, and 1 trapezoid, and I want you to pause the video and go cut them out. Okay, so now that you've cut out your figures, you should have 3 figures that fit nicely in this space. What I want you to do is lay them out as I've laid them out and trace them. You could trace them with a highlighter or a pencil, whatever works best for you. So pause the video again and go around and trace each edge of the figure in its spot. Okay, so now that we've cut out our figures and traced them, we're ready to unpack this definition of point symmetry. Again, point symmetry is when every part of the figure has a matching part equidistant from the point of symmetry in the opposite direction. Whew, that's a lot to think about. So point symmetry is really a type of rotational symmetry. All right. One thing I want us to do is go through and think about, does this image have line symmetry? Can this image be rotated to land in the same position? If so, that's called rotational symmetry, and we're going to find a degree of rotation. And then finally, we're going to decide if the image has what's called point symmetry. So let's start first with a review. Does this image have line symmetry? Let's think about that. Or you could actually pick up the image and start folding it to see if you could find some line symmetry. For example, pick up my plus sign here. I could look at it as an X and fold it. There's 1 line of symmetry. I could use that X and fold it again this direction. That's 2 lines of symmetry. I could look at it as a plus sign instead and fold it horizontally and vertically. So I'm up to 4, I believe I'm up to 4 lines of symmetry. All right, so this image absolutely has line symmetry. Just check that off. Check. Yes, it does have line symmetry. In fact, it has 4 lines of symmetry. Okay. Now to think about the point symmetry and rotational symmetry. Can you take this image, and I'm just going to put a happy face up here on top. Can you take this image and rotate it so that it fits into its original position? So here's my plus sign. I've traced it out. I can rotate it. If I rotate it 90 degrees clockwise, it fits back into its original position. I can rotate it 90 degrees again, and it fits back into its original position. And we're just able to rotate this image 4 times, and it will fit back into its original position all 4 times. So this object is oriented in the same position 4 times throughout one rotation. It fits in 4 times. Well, if we take our 360 degrees, which is one full rotation, and we divide that by 4, that means every 90 degrees of rotation, this image will fit back onto itself. And we could do that either direction. We could go left, counterclockwise, and this image will fit right back onto itself every 90 degrees. So this object has a 90-degree rotational symmetry. It does rotate onto itself. Now, to answer the question about point symmetry, we want to think about when every part of the figure has a matching part equidistant from the point. Well, here is our point of symmetry. This is where we're rotating it from, where all those lines of symmetry met up together. And it doesn't matter how you spin this, every part has an equal placement around the point of symmetry. So this does have point symmetry. In fact, it's got all 4 of these things going for it. It has 4 lines of symmetry. It can be rotated 4 different positions along one revolution. So it does have 90-degree rotational symmetry, and it's also got point symmetry. You guys, a very, very, very easy way to determine whether a figure has point symmetry is, can you flip it upside down? Can you rotate it upside down? So let's take our happy face again. It's on the top. If I rotate this image upside down, it still fits into its original highlighted area, so it does have point symmetry. All right, let's try again with our parallelogram here. Gosh, I couldn't get that word out. Our parallelogram. Again, I'm just going to put a happy face so I know which way was the original up. So this is where we started on the original shape. Now, first things first, does this image have line symmetry? Can you fold this parallelogram in half anywhere to create line symmetry? Well, if I try to fold it horizontally, you see that things don't line up correctly. If I try to fold it vertically, still doesn't line up correctly. If I try to fold it diagonally, it doesn't line up correctly. This parabola has no line of symmetry. There is no line of symmetry here. There's nowhere to fold this image in half to create mirror parts. All right, let's check the rotation here. If we take our image, and I've got my smiley face on the upside, can I rotate it so it fits back within its original shape? Boom. The answer is yes. This image, if rotated 180 degrees, so if rotated upside down, it fits back into the original parallelogram shape. So I've rotated this image 180 degrees. Okay, I can do it again. Half a spin, and it fits back into its original shape. Well, if we take our full rotation of 360 degrees, and we divide that by the 2 orientations, we hit every 180 degrees, there is rotational symmetry. Every 180 degrees, you can turn it clockwise or counterclockwise. Of course, that doesn't matter, and it'll fit back onto itself. Guys, this is the easiest way to determine whether something has point symmetry. If we can rotate it that 180 degrees, then it absolutely has point symmetry. all the parts are equidistant. So here we have an example of an object that has no line symmetry, but it does have point symmetry. Okay, we've got one more example to go here. Take a moment and decide if this trapezoid has line symmetry. What did you discover? Does the trapezoid have line symmetry? Can you fold it in half onto itself? I say yes. I say this image only has one line of symmetry though. I can only fold it vertically. I cannot fold it horizontally or diagonally. So this has one line of symmetry, so I'm going to check that off. This image does have line symmetry. If I start rotating this image, can it fit back onto itself within one rotation? Let's see. Spinning it. Okay, 90 degrees doesn't fit. 180 degrees does not fit. If I keep going, the image only fits back onto itself after returning to the original position. Remember, this was the upside. So this object is only oriented in the same position one time throughout rotation. Only one time. So if we take that 360 degrees and divide it by 1, of course, we get 360 degrees. So this object has 360 degree rotational symmetry, which really means it does not have rotational symmetry. You can do one full spin, but it really doesn't have a rotation of symmetry. Also, if we take our object and turn it upside down for that 180 degree rotation, it does not fit back onto itself. It is not equidistant from the point in opposite direction. That opposite direction is the 180 degrees we're looking at. So it does not have point symmetry. So we have three examples here. We have an example of an object that has both line symmetry and point symmetry. An example of an object that has no line symmetry but does have point symmetry. And an example of an object that only has line symmetry but does not have point symmetry. I hope this was a good review for you, and I hope it was a good introduction to what point symmetry truly is. Good luck studying.